Hello student, today we are going to discuss one of the most fundamental and intriguing laws in physics, and that is Newton's universal law of gravitation. This law explains the motion of objects under the influence of gravity. In this lesson, we will explore the concept of this law, its mathematical formula and its applications.
Can you tell me a little your law of gravitation?
Certainly, Albert. You see, the gravity between two objects is directly related to the mass of the two objects and inversely related to the distance between the two objects.
I see. So the bigger the object is, the greater the gravity.
That is only half of the equation. You have to take in consideration how far apart the two objects are from each other.
So let me get this clear. The closer the objects, the greater the gravity.
That is the other half of the equation. You see, you have to multiply the mass of the first object by the mass of the second object. Then, you divide them by the distance squared.
But when I look at your formula, there is a capital G in the equation. What does that mean?
That is my gravitational constant. It is a really small number that makes these big numbers, like the mass of a planet, more manageable.
I am partial to constants myself. What is the value of your constant?
It is 6.77 times 10 to the negative 11th power.
So, from the video shown, what have you understand? First, let's explore what gravity is. Gravity is the force that attracts two bodies towards each other. It is the force that keeps us on the ground and our planets in orbit around the sun. From the video, we saw that the gravitational force is the attractive force between any two objects with non-zero mass separated by a distance. So, does the apple fall towards the earth, or does the earth move towards the apple, or both move toward each other? It's actually a simple logic. This is the earth, and say this is minuscule object is an apple. The gravitational force both apply an equal force to attract each other object toward itself. So if the forces are equal, which one will accelerate it more? Based on the Newton's second law, we know that the force applied is the product of mass and acceleration. So the acceleration will equal a force over the mass. The acceleration is inversely proportional to the mass. If the mass is more, the acceleration will be lesser, and the mass of the earth is much more than the mass of the apple. It is the apple that accelerates towards the earth and not the other way around. Hope that makes it clear. Now, the question is, how do we quantify this force? To understand this, we need to understand a simple concept, and this simple concept is called the universal law of gravitation. According to the Newton universal law of gravitation, every object in the universe attracts each other object with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Say there are two objects, A and B, separated by a distance D. The distance between the center is considered the distance between the two objects and not this distance. Assume that the mass of object A is m1 and that of object B is m2. As the object A is bigger, let's assume m1 to be bigger than m2. The universal law of gravitation says that every object in the universe attracts every object with a force which is directly proportional to their product of masses and inversely proportional to the square of the distance between them. Repeat, the force is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. With this data, we can write it mathematically like this. So, if the mass of any object increases, the gravitational force will have more magnitude and more distance between them, between the two objects. The lesser will be the gravitational force. Directly proportional to the product of the masses and inversely proportional to the square of the distance between them. This can be written as F equal to G times with m1 times m2 over d squared, where G is the constant of proportionality and is called the universal gravitational constant. The equation can be modified and written as G equal to F times with D square over M1 times M2. Its value is approximately 6.67 times with 10 power of negative 11 Newton meter square over kg square. Let's consider an example to understand this law better. Suppose we have two objects, one with mass of 10 kg and the other with a mass 20 kg. The distance between them is 5 meter. Using the formula F equal to G times with M1 and M2 over D square, we can calculate the force of attraction between them. By substituting the data given, we will get F equal to 0.00004 Newton. This result may seem small, but it is significant when dealing with the astronomical bodies. For example, the force of attraction between the Earth and the Moon keeps the Moon in orbit around the Earth. Next, let's have a look at the application in Newton's universal law of gravitation. Newton's universal law of gravitation has numerous practical applications. For instance, it is used to calculate the force required to launch a spacecraft into orbit, the gravitational force between celestial objects, and the motion of planets and satellites. In addition, to understand Newton's universal law of gravitation, it is also crucial to know the value of gravitational acceleration. Denoted by the symbol G, gravitational acceleration is the acceleration experienced by an object due to the force of gravity. The value of gravitational acceleration varies from place to place and depends on the mass of the planet or the object. On Earth, the value of gravitational acceleration is approximately 9.81 meter over second square. Knowing the value of gravitational acceleration is essential in several areas of physics, including mechanics, fluid dynamics, and astrophysics. Here are some of the examples. Firstly, projectile motion. The value of gravitational acceleration is used to calculate the trajectory of projectile, such as rocket, missile. By knowing the value of gravitational acceleration, we can predict the height, the range, and time of flight of the projectile. And the second one, free fall. Gravitational acceleration is used to determine the motion of object in free fall, such as object falling from the height. By knowing the value of gravitational acceleration, we can calculate the speed of fall, impact of force of an object. The next one is planetary motion. Gravitational acceleration is used to understand the motion of planets, moons, and satellites. By knowing the value of gravitational acceleration, we can calculate the orbital speed, period, and the distance of this celestial body. And the last one is fluid dynamics. Gravitational acceleration is used to study the behavior of fluids in a gravitational field, such as the flow of river and the dynamics of the ocean currents. In conclusion, Newton's universal law of gravitation is a fundamental law in physics that explains the motion of the objects under influence of gravity. It is a powerful tool that has numerous practical applications, including space travel, astronomy, and satellite communication. It is essential to understand this law truly to comprehend the working of the universe around us. Additionally, knowing the value of gravitational acceleration is crucial in several areas of physics, including mechanics, astrophysics, and fluids dynamics. By knowing this value, we can make predictions about the motion of objects and study the behavior of fluids in gravitational field. Therefore, understanding both Newton's universal law of gravitation and the value of gravitational acceleration is necessary for a comprehensive understanding of gravity and its application.